Hey, grade 8. We're gonna discuss physics object today, which has to do with changing place. Now, how do you evaluate how fast does an object change its place from point A to point B? Well, that is done by three parameters, actually. First is the distance. Now, the distance is defined by how far an object moves. Well, distance is defined by moving an object from point A to point B. So you have to change position by applying force. Now, how fast does an object move from point A to point B is called speed. Now, speeding does involve many factors. However, the simplest form of evaluating speed is basically defining it as the rate of change of distance, meaning we time how long it took you to change your position from point A to point B. That gives the basic equation in motion of an object, which is speed. Now, speed traveled is defined as distance over time. Given that distance is measured in meters, speed v is measured in meters per second, while time is measured in seconds, which is basically gives us this equation. Speed meters per second is given by distance meter and time in seconds. Now, how do you apply this? Well, you either have to calculate speed, distance, or time. And to do that, you have to have two knowns, which is one of the parameters used in this equation. Now, why do we study that? Because we have to evaluate how objects move given distance, time, and speed. Now, if you check this example, shows you that we evaluated distance, we evaluated time in seconds, then we divided distance over time, and we got our speed denoted as v, which is 16 meters per second. Now, along with that is a consideration, which is the braking distance, defined as what is needed to be done to stop a moving object. And in this example, I think considered braking is something out of a car. Let's take our example as a car. Now, the time needed for you or to stop a car equals the time thinking about it and time actually do it. Now, all of that is called stopping distance. So stopping distance include the thinking distance, meaning how long it took you to decide to stop and when you actually hit the brakes. Now, the thinking distance, you don't actually do anything, you're just thinking about it. So, but that is considered out of the braking distance, which means you need to push the brakes. So, say you're moving in a car, you decide to stop. Now, the more the time or the distance covered during which you decide to stop is the first distance, which is called the thinking distance. Now, once you hit the brakes, that's called the braking distance that you travel after you apply the brakes. Now, that changes with many factors, means the road conditions, good or bad, wet, dry, icy, your car is well, your brakes are working well, your tires are good, and if there's oil in the car, you can hit the brakes. So also the speed of the car. The faster your car, the longer the braking distance would be. The mass of the car, bigger cars need bigger force to stop them. So that is more mass, more you have the braking system. Braking system. This is barking. It has to be changed to braking system. Anyways, you get the idea. Now, why is that important? Because for moving cars, it can be a matter of life and death if you don't press the brakes at the right time. So you have to be very, very aware of what it takes to stop a car. So you need to be aware of what time of the day is. Is your car big or small? And if the road conditions are wet, dry, and so on, because in some situations, it's a matter of life and death. Now, do remember that friction is your friend when you push the brakes, because you always know that friction actually reduces the energy that is, or actually opposes the motion of the car. So once you have more friction, the braking distance would be much less. And why is that? Because it opposes the kinetic energy as the car is moving. Because when the car is moving, it has kinetic energy. Now, who reduces the kinetic energy? Friction, which actually reduces the braking distance, which is good in some situations. Now, how can you represent motion using a graph? Well, simply by putting in the parameters of a speed. Now, how do you calculate speed? Distance over time. Or the distance is the output, where the time is your input, because you monitor time and you see how far the object moves. Now, the steepness, if you look at this comment here, the steepness of the gradient, or the inclination of the gradient actually shows you if the object is moving faster or slower. Now, the steeper is the line, that means the faster the object goes. Now, once you have the steepness in the line, that means the object is moving. However, when the line goes steady, which means there's no change in distance anymore, that means that the object has stopped. When you have distance and time, and you have like a flat line at one point, that means that's the final distance. You have reached this. Now, how would you calculate speed? Or simply take the parameters. At time 5, for example, distance was 8. And how do you calculate the speed? Well, distance over time. Distance was 8, time was 5, so that would be the speed at that point. Here's the example, another example, change from, from time 0 to time 4. So let's look at it, okay? This is time 0 to time 4. What was the distance at this point, where from 0 to 8, it was 8. So basically, this is how it's calculated. Distance is 8, time is 4, so speed equals distance over time, and that's it. Now, if the speed changes, that means it becomes slower or faster, we have ways to attribute that. Speeding means adding more velocity. So you change from slow to fast. So we call that acceleration. We're going to look at how we calculate that later. And if you change from fast to slow, that means you have reduced your speed, or we call that deceleration. And we can show it in a distance time graph like this one. For example, A represents moving up, B is a steady line, C is slowing down, and D is basically a straight line. How do you explain these parameters on a graph? Like this. A is increasing, B is constant, C is decreasing, and D is a flat line, which is 0. So this is basically, this is considered acceleration, steady, deceleration, and this is a stationary position, which means the car is no longer moving. Now, how do we represent the change in speed of speed in a graph? Well, that is the topic of the next video. However, once you change speed from point A to point B, or speed 1 to speed B2, that's called acceleration, and it is calculated through a parameter called velocity, which we will discuss in the next video. If you have any questions, please email me.